Hi, my name is Aziz Kapadia. Welcome to my course on Azure Fundamentals for Beginners. This is part 4 of the course. In previous video lessons, we learnt about create virtual network and subnet, create NSG or network security group and network interfaces, create Windows virtual machine, NSG configuration and how to set up rules for RDP. In this video, we will learn about availability set and availability zone, VM scale set and load balancer. Before we start with availability zone, we need to understand how Azure infrastructure is deployed across the globe. Azure data centers are located globally and they are interconnected. So data travels inside Azure infrastructure without being exposed to public internet. This slide displays overview of Azure infrastructure. Azure infrastructure is divided in geographies. An Azure geography contains at least one or more regions. A region is formed of a set of data centers and it may contain zones. A geography in Azure is a discrete market and preserves data residency and compliance boundaries. Some geographies have paired regions like UK geography has UK South and UK West regions to provide regional redundancy. Paired regions are physically separated and they provide protection against regional level failures like flood or other natural disasters. A region is a set of data centers deployed within a latency defined perimeter and connected through a dedicated low latency network. Azure availability zones are unique physical locations within an Azure region and offer high availability to protect our applications and data from data center failures. Each zone is made up of one or more data centers equipped with independent power, cooling and networking. Now, a data center contains many servers arranged on racks and they are further grouped in fault and update domains. When we create an availability set, then VMs are deployed in different fault and update domains. Fault domain defines the group of VMs that share a common power source and network switch. So in case of any fault, these VMs will be affected. Update domain defines a group of VMs that updated and rebooted at same time. Availability set protects against fault and update level failures within a data center. Availability zone protects against data center level failure. Let's create an availability set using Azure portal. First, we will create virtual network, NSG and load balancer for availability set. Open main menu and click on all services link. Azure will display categories and some featured services. Hover over virtual network and click on create link. Azure will open virtual network overview and plan page. Click on create button. Azure will open new page to create new virtual network. Click on create new link just below the resource group drop down list box to create a new resource group. Enter availability set demo RG in the name text box and click on OK. Enter availability set demo VNet in VNet name text box. Select UK South region and click on next IP addresses button or tab. On this tab, change IP address range to 10.0.0.0/22. Now click on add subnet button. Azure will open a panel on the right side of the screen. Enter availability set demo SN in subnet net name text box. Enter 10.0.0.0/24 in the subnet address range text box. Click on Add button to close the panel and add the subnet. Now go to Security tab. Select Enable option for Bastion host. Azure will display input controls to define new Bastion host. Enter availability set demo BH in Bastion name text box. Enter 10.0.1.0/24 in Azure Bastion subnet address space text box so that it would not overlap with the subnet we defined on previous tab. For the Bastion host to work, it needs a dedicated subnet with name Azure Bastion subnet. Without this subnet, Bastion host would not work. Name is important here. Azure automatically assigns this name to subnet. For the public IP address, click on Create New link below the public IP address text box. Azure will open a pop-up window. Enter Bastion host public IP in the name text box. Notice the assignment type is static and it can't be changed. Click on OK button to close the pop-up window. Keep other settings as it is and go to Tags tab. Create tag with name as project and value as demo. Click on Review plus Create button or tab. Once validation passed message is displayed, then review the details and click on Create button. Azure will start deployment. Now let's create Network Security Group or NSG. Click on Main menu and select All Services. Type NSG in the search text box. Azure will display services with matching keywords. Hover over Network Security Groups link and click on Create Link. Azure will open Network Security Group Overview page. Click on Create button. Azure will open a new page to create NSG. Select Availability Set Demo RG in the Resource Groups drop-down list box. Enter Availability Set Demo NSG in the Instance Details section name text box. Select UK South region from region drop-down list if not already selected. Go to Tags tab and create Project tab and Demo as value. Click on Review plus Create button. Once Azure validate all information successfully, then review the details and click on Create button. Wait for the deployment to complete. It won't take much time. Our NSG is ready now. We have to add rule to allow HTTP traffic to flow through virtual network. Open NSG properties page and select Inbound Security Rules tab. Click on Add button. Azure will open a new panel at the right hand side of the page. Enter 80 in destination port ranges and allow HTTP port 80 in name text box. Leave other settings as it is. Click on Add button to save the rule. Now we will create a new load balancer. Go to All Services page and type Load Balancer in search box. Azure will display all services matching with the keyword entered in search box. Hover over Load Balancers and click on plus Create Link in the pop-up window. Azure will open new page to create Load Balancer. Select Availability Set Demo RG Resource Group. Enter Availability Set Demo LB in the Instance Detail Name text box. Select UK South from the region list box. Click on Public option for type. Leave SKU as basic. For public IP address, select Create New option and enter ASDEMO-LB public IP in the public IP address name text box. Select Static for IP assignment. Go to Tags tab and create project tag with demo as value. Click on Review plus Create button and wait for validation to complete. Once validation passed message is displayed, then review the details and click on Create button. Azure will start the deployment process. Deployment process is completed and our load balancer is ready. Now we have to create backend pool, health probe and load balancing rule for the load balancer. Click on Go to Resource or the Availability Set Demo LB link to open Load Balancer properties. Click on Backend Pools tab and click on plus Add Link menu item. On the new Backend Pool page, enter ASDEMO PE pool in the name text box. Select Availability Set Demo VNet in the Virtual Network drop-down list. Select Virtual Machines from Associated to drop-down list. Click on Add button to create the backend pool. Our backend pool is ready. Let's create a health probe. Load Balancer uses health probe to determine the healthy machines. Click on Health Probe tab. Click on Add menu item. Azure will open a new page. Enter ASDEMO Health Probe in the name text box. Select HTTP from the protocol drop-down list. Enter 15 in the interval text box. Leave other settings as it is and click on OK button to create the health probe. So here load balancer will send ping request in every 15 seconds, and if machine returns true consecutive failure, then that machine would be marked as unhealthy and request will not be forwarded to that machine. Next, we have to create load balancer rule to serve incoming HTTP traffic using load balancer and virtual machines behind this load balancer. Click on Load Balancing Rules tab. Click on Add menu item. Enter ASDEMO HTTP rule in name text box. Enter other load balancing settings. Frontend IP address, load balancer frontend, protocol TCP, port 80, backend port 80. Backend pool ASDEMO BE pool. Health probe ASDEMO health probe. Leave other settings as it is and click on OK button to add the rule. Let's create an availability set. Click on Create a Resource in main menu. Type availability in the search box and select availability set from the list. Click on Create button. Azure will open a new form to create availability set. Select Availability Set Demo RG from the Resource Group list box. In the Instance Details section, enter Demo AS for Availability Set Name text box. Select Region as UK South. Azure automatically changes number of fault domains and update domains based on the selected region. Keep fault domains count to 2. change update domains count to 3. We want managed disk should be aligned with the VM so that it will be placed in the same fault and update domain with VM. Otherwise, if disk is placed in some different update domain or fault domain, and if that domain is not available, then our VM will not able to work. Click on Advanced tab. Here we don't have any proximity placement group. So go to Tags tab. Enter tag name as project and value as demo. Click on Review plus Create button. Once Azure displays validation passed message, then click on Create button. Azure will start deployment process. Wait for the process to complete. Now let's create 3 VMs in this availability set. Open main menu and hover over virtual machine and click on Create button. Azure will open a new form to create virtual machine. Select availability set demo RG resource group from the resource group drop down list. Enter VM name as demo VM01. For availability options drop down list, select availability set. Azure will display drop down list box to select availability set. Select demo AS. Now for VM image, select Windows Server 2019 data center image. Select size as V1S 1 vCPU 1 GIB. This is the cheapest VM we can create in the Azure. Enter username as demo user 01. Enter password and remember it because we will need it when we log into the machine. Enter same password in confirm password text box. Select none for public inbound ports. Click on next disks button. Nothing to change here, so click on next network tab. Select availability set demo VNet from virtual network drop down list if it is not already selected. Select availability set demo SN from subnet drop down list. Select none for public IP. We will use Bastion host to connect to VM, so no public IP is required. For NIC network security group, select advanced option and then select availability set NSG from the drop down list. We are not adding any load balancer here. Since we have created load balancer with basic SKU, Azure will not allow us to add it here. Now go to Management tab. Select Off options for all settings here. Then go to Advanced tab. Change VM generation to generation 2. Go to Tags tab and create project tag and demo as value. Click on Review plus Create button or tab. Once Azure displays validation passed message, then review the details and click on Create button. Azure has started deployment process. It will take some time. We have to create 3 VMs. So I will create 2 more VMs, demo VM02 and demo VM03. Come back after all VMs are ready. Okay, our 3 VMs are ready. Let's check availability set. It shows the 3 VMs and their fault domain and update domain. We can see they are placed in separate fault and update domain pair. We have to add VMs in load balancers backend pool. Open load balancers service from main menu If it is not in the main menu, then click on all services and type load balancer in the search text box. Click on load balancers. Azure will open new page with list of all load balancers. Click on availability set demo LB load balancer and click on backend pools. Click on AS demo BE pool. Azure opens AS demo BE pool settings blade. Select availability set demo VNet in virtual network drop down list. Now select virtual machine from associated to drop down list. Azure displays controls to add VMs in the backend pool. Click on plus add button. Azure opens a panel at the right hand side of the blade with the list of VMs. Select all 3 VMs and click on add button. Click on save button at the bottom. Azure will add machines in the backend pool. Our backend pool is now ready. Now we have to install IIS server on the VMs to serve the HTML page. We will use Bastion host to connect to VMs. Navigate to virtual machines page. It displays all virtual machines we have created. Click on demo VM01 and click on Bastion. Azure displays username and password fields to log in to VM. Enter the username and password which we had created while defining VMs. If it shows pop-up warning, then create exception and browser starts the Bastion session. Hint: use Google Chrome or Microsoft Edge browser if you want to copy paste text from your machine to host machine. Once Windows is launched, then open PowerShell. We will run these commands to install IIS server and update iisstart.html file. First command is to install IIS server. It will take some time to install IIS server on the machine, so I will speed up the video. It's done now. Next command is to remove iisstart.html file which is created while IIS server is installed. Last one is to create new iisstart.html file with some custom HTML code. Let's check the web server. Open browser and type http://localhost. It would display hello world from host demo VM01. Now we have to do this process on other 2 servers as well. I will do it behind the scene. We have 3 web servers ready to serve the requests. Let's check how load balancer works. Open availability set demo LB load balancer and click on front end IP configuration tab in left hand pane. Note down the front end IP. Here it is 51.140.150.152.24. Copy this IP and paste it in the browser. Now open another browser or open an incognito browser window and check responses. It changes according to where request is routed by load balancer. Refresh the browser if response is same and check the response. All 3 browser windows are showing different responses. Let's now look into virtual machine scale sets. Virtual machine scale set provides ability to create a group of load balanced virtual machines. Number of virtual machines can be increased or decreased based on demand metrics such as CPU usage, number of requests, or application insight or a predefined schedule. This elastic functionality helps in minimizing infrastructure cost. All instances of VMs are created with same configuration and base OS image. Vertical scaling is possible by changing central configuration, which is used to create VMs for scale set. So if we want to change the VM size or install new software, then we can edit configuration file and all VM will automatically be updated accordingly. Instances can be distributed across availability zone or availability set. By default, scale sets are created with 5 fault domains in Azure regions with no zones. If region provides zonal redundancy and this option is selected, then default value of fault domain count is 1. Scale set supports up to 1000 VM instances. For custom images, this limit is 600 VM instances. It can be load balanced using Layer 4 Azure Load Balancer or Layer 7 Application Gateway. Let's create scale set using Azure Portal. Click on Main menu and then click on Create New Service. Then type scale set in search box and select Virtual Machine Scale Set. Azure will open a new screen. Click on Create. Azure will open a new form to create scale set. Now for the resource group, click on Create New. Enter resource group name as Scale Set Demo RG. We want to create new resource group for this demo. Enter VM Demo SS in Scale Set Name text box. From the region drop down, select UK South and then in the availability zone check 1 and 2. Availability zone only enables if that region supports availability zone. For example, if we select UK West, then it will be disabled. So select the region which has availability zone enabled. Now in the install instance detail section, for image select Windows Server 2019 data center. From size drop down select standard B2S to virtual CPU. Enter username as demo user 01 and in password text box enter some secure string which you can remember. Enter same password again in confirmed password text box. Then click on next disk button. On this tab we don't have to change anything, so click on next networking button. Now here for the virtual network, click on create virtual network link below the drop down box and in the right hand panel change address range from /24 to /22 and the name of subnet to scale set demo -sn. Click on OK button to save details and close the panel. In the network interface section, one NIC is listed. Click on edit icon. Azure opens a new blade to edit the NIC. Change name to scale set demo -NIC. Select allow selected ports option in public inbound ports and select RDP 3389 from the select inbound ports drop down list. Click enabled for public IP address and click OK button to close the blade. Now click on next scaling button. Enter 1 in initial instance count text box and select manual radio button for scaling policy for now. Now configure the order in which virtual machines are selected for deletion during a scale in operation, keep default selection. This setting is to determine which VM would be deleted when scale in is required, or we manually reduce VM instance count. Click on Next Management button. On Management tab, for upgrade mode, select Manual Upgrade. For diagnostics, click on Off, then click on Next Health button. On Health tab, keep Monitor Application Health disabled. Now click on Next Advanced button. For spreading algorithm, select Max Spreading. For VM generation, select Generation 2. Click on Next Tags button. Enter tag name as type and value as demo. Click on Review Create button. Once validation passed message is displayed, click on Create button. It will take some time, so we will come back when scale set is ready. Deployment is now completed. Let's check the scale set. Overview tab shows there is one instance currently running. Go to Instances tab. We can see here one instance is running. Go to Scaling tab. We had selected manual scale while creating scale set, so that option is selected here. Here we can manually scale out or in VM instances by entering the number of instance count in the text box or dragging this slider. Enter 2 in the instance count text box and click on Save in top menu bar. Azure will start scaling up. It will deploy one more VM. We will see after deployment is complete. Scaling process is now completed. Let's go and check the instances. We can see now 2 instances are running. Now go to Scaling tab. We will set auto scaling rules. We need to set up scale out as well as scale in rules. Click on Custom Auto Scale option. Azure will display Custom Auto Scale screen. We can add multiple scale conditions such as based on CPU percent or disk write byte, etc. Click on plus add rule link. Azure will open a new form to define rule. First selection is for metric source. Keep it current resource VM demo SS. Now in criteria section from time aggregation drop down list, select average. In the dimension, select equal to operation and all values in dimension values drop down list box. Select operator greater than and enter 70 in metric threshold to trigger scale action text box. Enter 2 in duration text box. Select average in time grain statistic drop down list box. This means CPU percentage calculation will be done based on per minute average. Select operation increase count by and in the cooldown text box enter 5 minutes. Enter 1 in instance count. So this rule will increase 1 VM if average CPU percent remain over 70% for 2 minutes, which is calculated based on per minute average CPU usage. Cooldown period suppresses any scaling process within the cooldown time period. So here next scale up will happen only after 5 minutes from the previous scaling operation, which allows the matrix to stabilize. Now click on Add button to save the rule and close the panel. Next, we have to set scale in rule. Click on plus add rule again. Select average for the aggregation method. Change operator to less than or equal to. In the metric threshold to trigger scale action, enter 25. Enter 2 minutes in duration text box. Now in action section, select decrease count by in operation drop down list box. Keep everything else same and click on add button to save the rule. So this rule specifies that if CPU percent remain below 25% for 2 minutes and if VM count is more than 1, then Azure will remove 1 VM from scale set. Now click on save button to save the changes. If we have set up rule correctly, then in next 2 minutes scale set VM instance will come down to 1 again. Now let's check the instance count. It's showing only one instance is running and deleting one instance. We can see only one instance is running, another one is deleted. Go to scaling tab and check the run history. It is showing the same. Let's see how auto scale rule automatically scales out VMs when CPU usage goes above the defined limit. For this demo, we have to install an exe file on VM which simulates the CPU load. Click on Instances tab on the left-hand menu panel. Click on the running VM instance. Azure opens the new blade. Click on Connect tab on the left-hand side menu. Click on Download RDP file button and select Open. Click on OK button to start RDP session. If Confirm dialog box appears, then click on Connect. On the security window, click on More Choices link and then click on Use a different account. Enter your user ID and password and then click on OK. Select Yes if certificate warning is displayed. Wait for the virtual machine to fully launched. Now open the Internet Explorer and type http://download.sysinternals.com/files/cpustress.zip in the address bar. As Internet Explorer Enhanced Security configuration is enabled, choose to add the http://download.sysinternals.com domain to your list of trusted sites. When prompted for the file download, click on Open. Double-click on cpustress64.exe file and click on Extract All button. Now click on Extract in this dialog box. Double-click on cpustress64.exe file to run the application. To generate some CPU load, select one thread and click on Activate Thread gear icon. Right-click on the active thread and select Activity Level Maximum 100% from the context menu. Open Task Manager to check the CPU load. We want load should be higher than 70%. If CPU utilization is low, then activate more threads in the CPU stress tool. Leave this RDP session open and check the CPU percentage in Azure portal. Monitor CPU activity for some time. It will go up. We can see that CPU usage is around 100%. If it is not above 75%, then activate more threads in CPU stress tool. Check the instances. There more than one VM would be running. Wait for some time if it is not doing so. Check for run history. Azure has initiated scale up process as per the rule defined for scale up, and so one more VM is now running. Let's stop the thread and set activity level to low to reduce CPU load. After 5 minutes, Azure will start scale in process. Since CPU usage for VMs are lower than the threshold set for scale in. Let's compare the virtual machine scale set and availability set. Scale set consists of group of identically configured VMs. An availability set is a logical grouping of VMs within a data center spread across fault and update domains. Scale set automatically creates VM from central configuration, but in case of availability set, we have to manually create VMs. So if we want to create 3 VMs in the availability set, then we have to create all 3 VMs. But for scale set, we just need to define maximum number of instances and Azure will create VM based on the configuration. Scale sets are useful when load is unpredictable and fluctuates significantly. Availability set can be used when load is almost constant. When defining scale set, if we attach a standard load balancer, then all machines in that scale set will automatically added to load balancer's backend pool. For availability set, we have to manually create and attach VMs to load balancer. If we use a zone enabled region and select multiple zones for scale set, then VMs will automatically be spread in different zones. If we don't select zonal redundancy, then Azure will spread VMs in different fault domains. In case of availability set, it is manual process. For the scale set, various auto scaling options available, such as based on host metrics, application insights, or manually change the count of VMs. But in case of availability set, it's all manual. All VMs in scale set are created using central configuration and OS image. So they all are identical and we can change configuration to update VMs. In availability set, we can change VM size or disk size, etc. while creating VMs. If a machine goes down in scale set, then Azure shifts load on another machine and if required create another instance. But in case of availability set, we have to monitor it manually and take action accordingly. So as we can see, scale sets are better suited for large computing requirements and applications with variable load. Availability sets can be used for small applications and relatively stable load condition. That's it for now. In next video, we will learn about Azure CLI and PowerShell modules, Azure Active Directory, Azure App Service and host ASP.NET app with Azure App Service. Until then, practice with availability set and scale sets. Remember to clean up the resources once you are done with it to avoid any costs especially if you are not using Azure free account. Delete the resource group, which will delete all the resources created in that resource group. There are some useful links on this slide for some Azure documents about high availability. Thanks for watching this video. Please leave your comment below. Also, let me know if you have any suggestion. It will help me in preparing better content. Please click on subscribe button and share it with somebody who you think this could help.